So good afternoon again. Thank you for joining this webinar. My name is Teresa Schmeikova, and the webinar will be on burned area mapping with Sentinel-2. And then we will be looking at Sentinel-2 data, multispectral radiometer, and first tell you a few words regarding the organization of the webinar. First, I will give you a short overview on the Portugal wildfires and Sentinel-2, and then very shortly introduce RUS Copernicus, or the research to support service for Sentinel core products. Then we will move on to the practical part, during which I will show you how to download and process Sentinel-2 data, and how to retrieve burned areas, and also how to register to RUS and request virtual machine in case you want to repeat the exercise yourselves later. And finally, there will be 15 minutes at the end of the webinar for question and answer session. Please feel free to post the questions during the entire webinar. We will try to answer as many questions as we can. For the questions that we don't manage to answer, we will provide compiled Q&A sheet later this week on the RUS training website where you have registered. So the duration will be approximately 1 hour and 15 minutes with additional 15 minutes for the Q&A. And after the webinar, you will receive a follow-up email containing the instructions for repeating the exercise yourselves and access all the training material. So short description again of the study area. So we will be looking at the area in central Portugal, where this year there were on the 17th of June 4 deadly wildfires erupted across the central Portugal. It turned to additional 156 fires during the night of 17th to 18th June. And majority of them occurred in the mountainous area approximately 200 kilometers northeast of Lisbon. And by the evening of 20th June, a total of almost 45,000 hectares of land was burned. We will be looking at the burned areas with Sentinel-2, or the Copernicus optical vision, color vision of Copernicus. This was just a short video to have a look on the acquisitions, but that's a few words about Sentinel-2 Copernicus satellites. So a Sentinel-2 constellation consists of 2 satellites, Sentinel-2A and Sentinel-2B. They're both in polar orbit and faced 180 degrees to each other. There are multispectral instruments with 13 bands, and as you can see in the table below, they have the visible bands, so band 2, 3, and 4, and also the near-infrared band have 10-meter resolution. Then there are some vegetation edge bands and snow and ice cloud discrimination bands. So in the shortwave infrared part of the spectra with 20-meter resolution, and some atmospheric bands with the 60-meter resolution. This is an important thing that we need to remember when processing the data. So each of the bands, or there's 3 groups of the bands with different resolution, meaning the same extent, however different number of pixels. And the last thing about Sentinel-2 is that it has very high revisit frequency. So it is 5 days at the equator, which is very useful for us if we want to map the extent of the fires continuously. Okay, now a few words about the RUS service. So RUS it stands for Research and User Support for Sentinel Core Products, and it is an initiative that is funded by European Commission and managed by ESA. And its main objective is to promote the uptake of Copernicus Sentinel data and to support R&D activities. So it's an open and free platform. So at no cost to the users. It's scalable, and it offers a powerful computing environment that hosts a suite of pre-installed toolboxes with a number of well-known tools such as the SNAP, QGIS, Orfeo toolbox or development environments such as Eclipse and so on. You can, of course, always request an additional software to be installed, or you can install it by yourself on your virtual machine. Since if you request a virtual machine, you have full administrative rights. So you can install any software, providing, of course, you have an appropriate license for that software. Okay. So in addition, RUS offers specialized remote sensing help desk that can help you with any inquiries you might have about processing of Sentinel Copernicus data, whether it's Sentinel-1, 2, or 3, or in recent future it will be also Sentinel-5. And we also provide training activities such as webinars, such as this one, or face-to-face events such as our webinar that will be happening in Portugal in February. Okay, so to access RUS, you can have a look at 2 websites, or you can follow us on RUS Copernicus on LinkedIn or on Twitter to get the latest news about webinars or other events. And as you have probably seen, you have registered on the RUS training website, so let's just have a quick look there, what you can find there. Okay, so if you click on training, you can see all the upcoming trainings, and you can also see the past training sessions. And if you go to the past training sessions, you can find then the recording of the webinars and the Q&A answer sheets, question and answer sheets, sorry. Okay, so that was just a quick look on our training platform. And then let's have a look on the Copernicus, RUS Copernicus website. Okay. So this is the RUS platform where you can read more about what RUS is and who it is for. And you can also register and request your own virtual machine. So just quickly, a few words about the computing environments. So here you have a list of software that is by default provided on the virtual machines. And you can also, based on what you require, you can see the different, we classify users to 3 different levels. And you can see for how long the virtual machine you requested will be available to you and what are the general specifications. Of course, it's always on your discussion with the front desk when you request a virtual machine. So what to do if you want to request a virtual machine? You can log in, or first you have to register for the Copernicus SSO account. So you would fill all this information, then you would receive an email, activation email, and once you receive that email, you can go back to RUS Copernicus and you can log in. I will not register because I already have an account and virtual machine. Okay, perfect. Okay, and once you log in, you will be redirected to your dashboard, or you will have a new tab up here, which is your RUS service, in which you can view your profile, you can see your dashboard and your training. So let's go to your dashboard. So for me, my dashboard already consists of 2 virtual machines that I have requested previously, and one of them I will be using for this webinar. However, if I did not have any, or if I wanted another one, I would use this button to request a new user service. So I will just guide you through how to do this. It's quite simple. So you have to answer a few questions for us to be best able to determine what virtual machine would be appropriate for you. So, okay, let's just go through that. So, have you already downloaded Copernicus data? Yes. Have you already handled and processed Copernicus data? I would also say yes. And in this area, that is especially interesting, because here at the end of the webinar, I will provide you with a code. And if you would like to redo the webinar on the virtual machine, you can enter the code here. I will for now just enter something. But if you enter the code, you will get these two options. So either you only want to complete the exercise and do not need the virtual machine for any other purpose, or in addition to the exercise you want to use the virtual machine to process other Copernicus data and to do other projects. So if you select the first option, you will be directly forwarded to the submitting the request. If you choose the second option, you will be directed to provide more information about your additional project. So let's do that for now, so I can show you the options. So you will be asked for thematic area. So for my case, I will choose other. What kind of operations you wish to perform. So I'll choose basic processing. Here you can choose from self-downloading service, so either you wish to download the Sentinel data yourself, or you can use the RUS downloading service, which means that you specify the data you need and they will be preloaded on your virtual machine for you. So for me, I'll choose self-downloading. And then here you have to, best as you can, describe the activities or the project that you plan to use the virtual machine for. And this will be used by the front desk to best fit the virtual machine to your needs. So if you require additional software, if you have a setting such as virtual machine size and such in mind that you wish to have, you can request it here, and the front desk will assess it and let you know. So for me, I will just say, which is just the description of my project, so I'm not really giving any information. And here I will name it as webinar. Click next. So in the last part, you will be requested to select the data you plan to use. Unfortunately, at the moment, you have to do this even in case you select self-downloading. This is for statistical purposes and so on. So I will select Sentinel-2. I will select area of Portugal. I do not plan to do multi-temporal analysis, and additional specifications be none. Okay, and as the final step, I can review and then submit my my request. So here's the review of my request. It's not very very comprehensive, so this would not be very good request to submit. However, just for the purposes of the demonstration, it's okay. So and here you have terms and conditions of the service. It specifies who the service is for, and so on. So I will not actually submit the request. As I said, I already have a virtual machine that I will use for this webinar. So let's go to it. So you can go to it by, once you have a virtual machine, you can go back to your dashboard. Also, once you submit this request, the request will appear in the dashboard. So I have two open requests. So it means I already have the virtual machines operational. However, if I now submitted the request, I would have now a request here that would read submitted, and then the status would change as in accordance with the development of the project. So I can access my virtual machine from here. You will receive, once you receive the virtual machine, you will also receive the login details. Okay, so I will access my virtual machine, and so I have here my username and my password, and then I will log in, and this is the RUS desktop. You have all the software that I have on my virtual machine. I have here on the desktop. I have also the shared drive with bigger storage here, and then the home folder with all the settings. So Otherwise, it's a Linux virtual machine. So if you're experienced with Linux, it's quite easy. If you are not, it's still pretty straightforward with everything. So what we will start with will be, now we will go to the actual exercise. So what we will start with is downloading the data. So we can go to the internet browser. It will automatically open, in my case, on Open Access Hub, but otherwise here is the Copernicus Open Hub address. And here I will go to the Open Hub, which will redirect me to the graphical interface. So unfortunately, if you want to download the data from Copernicus Open Access Hub, you need to register. So unless you already have an account, you need to fill up another registration here. And then once you have the registration, you can log in. Okay, and if your login is successful, you can start to select your data. So first, let's zoom into the area we want to have a look at. So I need to first switch from box drawing mode to pen. Okay. And I can then switch back again and draw my area of interest. It will be here. Then I can open the search menu here, and I can set the dates or bounding dates for the search. So I would like to search for images as of or starting from June of this year, June 4th to be specific, and I would like to end July 4th, as the fire has occurred on the 17th. Okay. And I need one image before the fire has occurred and one image as soon as possible after. Okay, so I do not need to, I need to first select which mission I plan to use. So we plan to use Sentinel-2. We do not need to set satellite platform. We are okay with both Sentinel-A or Sentinel-B. However, we will set a product type, which in our case will be level 2. So it's S2 MSI 2 here. This means that I am only interested in products that already have atmospheric corrections applied to them. This is always a good choice if you want to perform analysis on images from multiple images, such as we will do. And also, I'm quite lucky because the level 2 images or level 2 products are only available over Europe as of April 2017. For all other areas and previous to that date, you have to actually perform the atmospheric corrections yourself, which is rather time consuming, so I will not actually be talking about it during this webinar. However, generally you can use Send to Core and it provides same results as these already pre-processed. Okay, so I only select mission and product type and I can click search. Okay. So, and I have received 2 results. I will change the mode again to pan, just to view all my results. I am interested in this tile here. And that tile, you can see that there is each tile in Sentinel-2 has its own unique ID. So the ID consists of the UTM zone and 3 letters, a combination of 3 letters. So the tile that I'm interested in is the T29 TNE. And one image that I'm interested in is from the 4th of July, which is this one. So to download it, I'll just go and download here. And then I am interested in one from the 4th of June. So I'll go on the bottom and find again T29 TNE. from the 4th of June, and click download. Okay, so now both of my images are downloading, and I can minimize my browser window, and I can go and to Snap. So I already have the images downloaded, pre-downloaded, so this doesn't take any time, so we don't waste time. But when you download the images, you need to go to the folder where you have downloaded them, and you need to unzip. So the images are in a zipped format, zipped archive, and you first need to go and unzip each of the products to a folder which has a suffix safe. You will see it now. So I now opened Snap, and I want to import my images that I have just downloaded. So I will click here on Open Product. I will find the folder that I have downloaded the images into. Okay, and that's here. So I see these would be the 2 images that I have just downloaded. However, I have already unzipped them prior to the webinar, so these are the 2 unzipped folders. You can see the suffix safe here. And I will open them. So I need to go to open it in Snap, I need to go into the folder, and I need to click on this product here. So it's an XML file, and I click open. Okay, and I see that my product is now loaded here, and I will also load the second one from the 4th of July. So now let's have a first look on the images. If you expand the menu here, you can see several folders. Here we have the bands, the 13 bands of Sentinel-2. They are both, products are exactly the same in structure. So the first thing we will do, we will just visualize our product. So to do that, you can right-click the product and then go to Open RGB. Okay, and we will use a scheme, color scheme that's most beneficial for looking at burnt areas. So we could use a normal color or natural color composite, which would be combined of the red, green, and blue bands. However, in our case, we will choose different bands. So we will choose band 12, which is shortwave infrared. We will choose band 11, which is also shortwave infrared, and we will choose band 8A, which is near infrared. And these give us the best separability. You can save your, if you need to apply the same color scheme or you apply it to multiple images, you can save it so you don't need to set it every single time. So I can save it here. I already have it, so just rewrite it. Okay, and then I have one that I have named burn area, and it consists of these 3 bands. So I click OK. Right. And I will do the same for the second product. So I'll go again to Open RGB, and here in the drop-down menu, I can find the burnt area that I have saved before. You see again it's band 12, 11, and 8A, and click OK. Okay, so now I have 2 views here. To see them side by side, you can go to Window and Tile horizontally. And then you can, to center the views, you can see the navigation pane down here, and click on A, which centers both views in the middle. Okay, so the next step we need to do, as you can see in each of the products, you also have a folder that's called masks. This contains all the quality masks and other masks present in the product. We will be using the SCL masks, which are created during the atmospheric correction, and they classify the pixels into the cloud, low clouds, medium clouds, high clouds, and thin cirrus clouds. So these will be the categories we will be using. We will be using the medium, high, and cirrus groups. There's quite a lot of misclassifications in these groups. It depends from product to product, but for our purposes, we will use these, and they will serve quite well. So unfortunately, when you want to apply the masks into the products, it is rather a long operation, or it takes rather a long time. So what we want to do previously is actually subset the products, because we don't need to apply the masks to all bands, only to the bands we are interested in and only to the area we are interested in. However, unfortunately, if you do the subset the masks folder is lost in Snap. So what you have to do first is convert these masks into a binary band that will be saved in the bands folder. So how to do this? We will do this one by one for the products very quickly. So you can right-click on the product again, and the first thing here is band math. So if you click on the band math, it will open this this dialog, and here we can specify the band name, so the new band name, which will be cloud mask, with the underscore here. It must not contain any spaces or special characters. We will unclick the virtual, since we want to save the band physically, not just to have an expression, and we will edit the expression. So here we will set a conditional statement which will stand like this. So if, and now we have to find the SLC mask. So you see that the product here which we are browsing is product 1, this one. So let's let's scroll down and find the CL mask, sorry, and they are here. So as I said, we will be using the SLC cloud medium, and we will create a sum of all these bands. So these bands are binary, and they have either value 0 or value 255. So we will add them all together, the ones that we want, and then cirrus. And if our sum is larger, sorry, smaller, not larger, I'm sorry, smaller than 255. So if even one of the bands is classified as, if even in one of the masks the pixel is classified as cloud pixel, it's going to be now set to 0, and if it's not if it's in even one classified as cloud, it will be set to 1, and if it's not, it will be set to 0. I apologize, got a bit tangled. Sorry. Okay. So this is the condition. Since we need to repeat exactly the same condition for the second product, I would suggest you to copy it. And you can click OK to apply. And once the band is calculated, you will have a new view that opens, and this one corresponds to the first product. So we can drag the view next to it here, and we can repeat exactly the same process for the second. Be careful, in both products the new band has to be named exactly the same. Okay. So, and I will edit the expression. I can paste my expression that I have said before here. However, be careful, because now we are looking at product 2, so we actually have to change all of these values here to 2. Okay, and now we can apply again. This is also a good way to make sure that you are applying exactly the same formula. So click OK. And now if I go here, I can see that I have a cloud mask band that I have just created here. And just to center the views, I will again click in navigation pane to the eye here. And this is my cloud masks. So you can see that there's quite a few misclassified pixels, such as some ocean pixels, also the coastline. Some roads are misclassified as clouds. However, for our purposes, this is good enough at the moment. And we can move on to a further processing. So the next steps, we will build a graph. And this we will do since we are going to perform the same analysis for both of the images, and we can therefore take advantage of the batch processing option in Snap. And it allows us to define a processing chain by creating a graph and then apply it to a set of images. So first we need to create the graph. So we can go to Tools and Graph Builder. It will open a new window, and at the moment you can see we only have two operators here. We have read and write, so you read the input product and write the output. Another nice thing to use Graph Builder and batch processing is that no intermediate products are created, so you actually save space, and also you have way less intermediate files. First operator we can add, it will be the resample operator. So as you have seen when I was talking about Sentinel-2, not all the bands have the same resolution, and many of the operators in Snap cannot handle products that have different sizes of the bands in one product. So we need to resample all the bands in the product into exactly the same resolution. So we will add the resample operator, and we can do this by right-clicking on the white space and then going to Add, Raster, Geometric, and Resample. Okay, and we have a new polygon here that says Resample. We also have a new tab here that says Resample and corresponds to our operator. Then we will add another one, which will be Subset. So again, we will go to Add, Raster, Geometric, and Subset. The next one we will add will be band math. So we will calculate the normalized burn ratio. I will explain what the normalized burn ratio is later. However, it is basically the same approach as we have used for calculating the cloud mask. The problem is that in Graph Builder, the band math operator only outputs the calculated band. So we also need to add band merge operator to then have also some of the original bands that we will need for further processing, plus the normalized burn ratio band that we will calculate. So I will add the band math operator here, and I will also add band merge operator. Okay, and now I can click here and I can say connect graph. Okay, so you can see that we need to have each, of course, input connected to the operator to which it belongs. And as I said, we have the band math here, but if I use only the band math like this, the output is only going to be one single band. But I want to keep some bands from the original product, so I will also connect the subsetted product to the band merge. And in this case, I will retain the bands from the original product plus the calculated band, and I will all write them. So if I was only processing one single product, I would now set my parameters in the tabs here, and I would process the product. However, if I am using the batch processing, I must not actually touch any parameters here, and I will go here and save my graph. Okay, so I can save it as, it's an XML format, so I will say save my graph XML. There we go, and now it's saved, and I can just close the graph builder, and I can go back and I can go to batch processing. It will open another window. Okay. And I can use the icon here to import all open products. So it's very useful since I can just do one click and it will open both of my open products. You can see that it inputs them with the file name that I have used to open the product in the first place, or import the product to Snap. This is a bit problematic since what happens in batch processing is that the output has exactly the same name as the input file. And you can see that these both have exactly the same name. So what happens is that the result of the second one will override the result of the first one. So to avoid that, we need to unclick the keep source name, product name here. This is very important if you have Sentinel-2 level 2 products, because that's mostly where the problem occurs. And then we will load, sorry, you can also do refresh. In this case, here the name changes, but the product name did not really change. But it also loaded all the metadata information, so the date of the acquisition and so on, just for your information. And then we can load the graph. So I will click on load. I'll go to the folder where I have saved my XML graph, and I will load it. And now you can see that I have more tabs here corresponding to all the operators that I have added to my graph. So the first one is resample. Okay. And if I use the resample operator, I can use 3 different ways how to resample the product. So the first way is to resample by a reference band from the same product. The second way is to set target width and height in pixels. So you can set here, or you can set resolution. And all of these will be used to calculate either the pixel size in this case or the number of pixels in this case. However, for us, we will be resampling to 10 meter resolution, as is for the optical bands. So we can actually use one of the optical bands to resample all the other bands by. So we click here, and we will set band 2, as that's the blue band. We can use it for resampling our products. So the next step then will be subset. Okay. So you can again subset in 2 different ways. You can either subset your bands, or you can subset the product spatially. We will use both. So first, if you do not select any bands, all the bands will be output. If you start selecting, if you want to select multiple bands, you have to click Ctrl or press Ctrl, and then you can select multiple bands. So for further processing, we will need the band 3, band 8, and band 12. And of course, also the cloud mask that we have created. Okay, so those are the 4 bands that we will carry forward and use for any further processing. So it's the green band, near infrared, and shortwave infrared, and cloud band. And then we will use also the spatial subset. We will use the pixel coordinates, since we have 2 exactly same tiles for the Sentinel-2 products. They have the same extent. So and also the pixel coordinates are the same. However, if you're using, for example, Sentinel-1 or other satellites, you generally want to use the geographic coordinates, because the pixel coordinates will vary from product to product. So I will set now my X starting point, or these 2 correspond to upper left corner. So I want my upper left corner vertical coordinate to be 5040, and horizontal 4800. Then I set the width and the height. Okay. Maybe this is better view. Okay, and we can move forward. So then we will go to the band math. Okay, So here I will shortly explain what the normalized burn ratio is. And I will need some slides for that, so I will go back to my presentation and just show you this. So the normalized burn ratio is derived from the fact that healthy vegetation has a very high reflectance in the near-infrared part of the spectrum and very low reflectance in the shortwave infrared part of the spectrum, as compared to bare soil and recently burned areas, of course, which have low reflectance in the near-infrared and high in the shortwave infrared. So we calculate this normalized ratio, and then we can see that if the value of the normalized burn ratio is low, this will most likely correspond to bare ground and recently burned areas. And if the value is high, it will most likely correspond to healthy vegetation. Of course, this is calculated for each product, so there is no temporal, we cannot differentiate between the bare ground and burned areas quite yet, but for that we need to use the difference between the normalized burn ratios of the two products, so the product before the event and the product after the event. Okay, so let's go back to our machine, virtual machine, and we will just name the band NBR, normalized burn ratio. We will set the no data value as NaN, or no, not a number, and then we will go to edit expression, and we know that the near infrared band is band 8 and this shortwave infrared band is band 12. So we need to do the normalized ratio, so we will go band 8 minus band 12 divided band 8, band 8 plus band 12. Okay, so this is our normalized burn ratio. We click OK, and then we just check the band merge. So in the band merge, we have the 4 bands we have selected in the subset operator. Oh, okay, now I have clicked, so I actually have to select all of them, otherwise it will subset again. Be careful about this, because if you don't select any, all the bands will be merged. If you select one, the output again will be only the one. So if you by mistake click like me, you'll then have to select all of them. And you see you have the normalized burn ratio here, we have just calculated, and then the bands we have selected in the subset. And then we can go to the right folder, and then here do not change the name. The name corresponds to the product, but this is the only way how you can actually prevent overwriting the product over one another. And then here you can select the folder where you want to save. So this, if I now run this process, it's going to take approximately 5 minutes. It's not long at all. However, for the purpose of the webinar, I will not run it since we already have quite significant delay. So I have the products pre-processed before the webinar, and now I will just show you how they look. So I will actually close this, and I will load them from the processing folder where I saved them before. Okay, so these are the 2 products that would have been created if I now run the process. And I will just click on the dim file to load it. Okay, and then I will open the second one. So this one is from June, and this one is from July. And we can now have a look at the normalized burn ratios, how they look. So this one is the first one. And double click again, and it will open the view. The second one, I will just drag the views like this, so I have them next to each other. And there we have the normalized burn ratios calculated. So you can quite distinctly see the differences. So this is the burnt area. We have also one burnt area here and here, as compared to this area, which has been burnt before the acquisition of our first product. So it remains in both. So you can see that the histogram stretch in both products is quite different. So to compare best, we probably need to apply it exactly the same. So we just select this view. It has the yellow frame here. And we can go here, apply to other bands. And here we can select product 3 NBR, so that's this one, and apply exactly the same stretch. Here we want to, yes, apply the same stretch, so no. And now they are perfectly comparable. So you can see the NBR values visualized exactly the same. So you can see that this area has not changed very much. The difference in the acquisitions of our images is only 1 month. So there is not much regrowth that we can see. And we can see all the new burned areas. Okay. So the next step, since as I have said before, we now need to calculate the difference between these two. We would ideally want them to be in the same product, so we can use them for calculating new bands. So what we will do now is a collocation to join them together, and we will do this going to raster, geometric tools, and collocation. And again, we have a new window here, but you can see here that it automatically loads product 1 and product 2. So that's not good. We need to change this to product 3 and 4, since these are the ones that we have just preprocessed. We can change the name here to anything that tells us more about what we are doing now. And then you can see that this is the master product and this is the slave product. So all the bands and the master product will keep their original name, plus they will be appended with M, but for us we want to change it to June. And all the the bands from the slave product will be appended with S, so we want to change that to July. Very well. So again, now I would run it. However, again, it takes from 1 to 3 minutes, so let's skip, and I will just load a product that I have preprocessed before. So, okay, so I will close and open a new product. Not a new product, but a preprocessed product that I would have created if I clicked on Run. So that is here, and if we look at the bands, you can see that now all the bands from the product from June have appendix here, June, and all the ones from July have July. And then you have a new band created that's called collocation flags and shows you the precision of the collocation. Okay, so the next step we need to do is yet again create a mask. So you can see that there's quite a lot of water bodies, and what can easily happen in this case is that we will get the same return from water, same difference from water bodies as we get from burnt area, from the difference in burnt areas. So we need to mask the water bodies. If I zoom in, I can show you this effect. So you can see, for example, in this area, this is mostly depending on sun glint. So in this area, you actually have quite higher reflectance that you would or high NBR, sorry, in this case, than you would expect. And in this case, you have a much lower one. So what will happen if we make a difference will be that all of these areas will be actually classified as perhaps low burn severity areas, which is of course nonsense because this is a river. So we need to mask all the water bodies, and for that we will use a ratio that is called the normalized difference water index. Again, I will use just a quick slide for that. That is right here. So the normalized difference water index, again, similarly as the normalized burn ratio, only this time it looks at water. So it uses the green band where water bodies or open water has quite high reflectance, and the near infrared where water bodies have very low reflectance. But otherwise the ratio is calculated similarly. It just uses band 3 or green band and near infrared band 8. So if then NDWI is lower than 0, it will most likely correspond to land, while if it's higher or equal to 0, it will correspond to water body. Okay, so to go back again, we will now click on our product 5 or our collocated product, and we will click here again and do bandmath. Same dialog we have already seen several times today, and we will name it cloud water mask. So why am I saying cloud here? This is because I would like to create one mask band in which any pixel that corresponds to cloud or water in any of the two products will be classified with 1, and if it does not contain any cloud in any of the products, or in June, or in July, or is not a water body, it will be classified as 0. Okay, so again I will unclick the virtual since I want to save it, and I will go to edit expression. And this expression is rather long, but it's not difficult to understand, so it will be another conditional statement which will use the cloud mask from June, and if the cloud mask from June is larger than 0, or if the cloud mask from July is larger than 0, or, and now we apply the normalized water index, so if, and we will only use the one of the products, of course, to calculate the normalized water index. Okay. We will use band 3 minus, band 8 divided by band 3 from June, plus band 8. And if this ratio is larger or equal to 0, so if any of these conditions is true, then we assign 1, else we assign 0. So if there's errors, it usually appears here. And let's just quickly check. Okay, so cloud water mask, here we have our expression, and then I click OK. And a new band is created, which is called the cloud water mask. Okay, so now we can see that all the water bodies have been picked up right here, as well as both the clouds for all the clouds for from both of the products. So here and here are some cirrus clouds, and then of course, as I said, there's some misclassification in the clouds, cloud masks and the original cloud masks for roads and so on. Okay. So the next step will be to calculate the burn area severity. So at the moment we have the burned normalized burn ratio, but as I said, we need to calculate the difference between the normalized burn ratio before and after the event. So let's do that. We will again use the bandmath. You can automatize all of these steps, but then you only receive the final product. So for the purpose of the webinar, I'm showing it step by step. So again, I will use bandmath, and I will use the burn area, the relativized burn ratio, RBR. So just to quickly explain what the RBR is, let's go back to the presentation. So as I said, we will be calculating a difference. However, if you're only calculating a difference between the NBR before and after the fire, that is an absolute difference, which can present problems in areas that have low pre-fire vegetation, where the absolute change in the pre-fire and post-fire normalized burn ratio is very small. So in such cases, usually the more robust choice is to use the relativized burn ratio, or the RBR, which is calculated as the delta NBR here divided by the pre-fire NBR plus a coefficient of 1.001. Okay, so this is the formula that we will now use to calculate the relativized burn ratio in the bandmath, or the raster calculator. Okay, so we will name it RBR. We will again uncheck the virtual. We will again go to edit expression, and we will use an expression where we will say that if our cloud water mask is not 1, so is not containing any cloud or water pixels, then we calculate the normalized burn, the relativized burn ratio. Okay, so this will be a conditional statement. If cloud water mask here equals 0, then I want to calculate the RBR, which is NBR June minus NBR July divided by NBR June, NBR June plus 1.001. In case that the cloud water mask equals to 1, or does not equal 0 in this case, we assign an AN, or not a number. Sorry, I need to have a typo. There we go. So now there's no errors, and I can click OK. And again, I can just click OK to calculate the band. So now we are starting to be a little bit too populated, so let's close all the views and just keep our 1. There we go. Okay, so now we can see that the burned or newly burned areas are much more prominent, so we can see them much better. We can also see that all the areas that correspond to clouds or water are masked out and are actually corresponding to no data values. And now we could export our results to any other software such as QGIS, and we can use them for visualization. So first let me just create another mask very quickly, which will be mask only of the burned areas. We will apply a threshold that I will explain in a second. So it will be RBR underscore, for example. Okay. And in this case, we will only want such pixels where RBR is larger than 0.27. The value 0.27 corresponds to moderate burn severity areas. So we only pick areas that are classified as moderate burn or higher to get sort of a mask that we can then overlay over high-resolution satellite data or export to Google or Earth or other. So if this condition is true, then we write again the relativized burn ratio, or we set to no data. Okay, just very quickly. So now we see the mask and all the no data around. Okay, so now what we can do because at the moment we are working in a DIM format, a DIM format that is native to Snap. However, it's quite difficult to import to any other software, so we would like to export it to something more manageable such as GeoTIFF. So we can go to export here. Be careful to select first the product that you wish to export here, and then you go to export, GeoTIFF. And you can also apply a subset when you're exporting. So you can click on subset, you can apply a spatial subset, or you can apply band subset, which is quite useful in our case, because then we can only export the bands that are actually our result bands. So these two. So I only check these two, and I click OK. And I save this as a TIFF into my processing folder. Okay. So while this is saving, I can minimize Snap, and I will go to QGIS. And I will just quickly explain the visualization we will be using. So I'll go back to my presentation. And we will be using a color map based on classes that were defined by the United States Geological Survey. They proposed a classification to interpret the burn severity. You will see in a second that there's quite a lot of pixels classified as low severity burn, which are quite clearly not related to a fire event, but they are related to the degraded vegetation due to a severe drought that preceded all of these fires, or was during the period between our images. So we now, before we used this threshold 0.27, and now we will in QGIS apply this color mask to our data to actually see, to visualize the burn severity. So let's go back. To import our GeoTIFF that we have just saved, we will go here. And we will import a raster, and it will be imported to our layers panel here. And then the two bands are opened in RGB view. However, we only have two bands. So this is how it will look. And to change, we will go to properties. And here we can change multiband color to single band pseudo color, which will enable us to implement the color map. We will change here from the interpolation from linear to discrete. And then, since the color map, I have predefined the color map, and if you are repeating this exercise on the virtual machines, you will be provided with this file. I can open my predefined color palette that I have saved here. Say open, and I have all my classes with all the appropriate thresholds, and I'm applying them to band 1. So in this case, the band 1 is the relativized burn ratio raster, not without the full raster. So that contains all of the classes, not just from moderate low severity burn. Okay, and we can click OK. And now we can actually assess properly the burn severity in our area. So if we zoom in, and in a QGIS you can use this to create maps, you can use this to overlay with roads and assess the damage that was done. Okay, so now if I want to just use the masked band, I'll go to properties again, and I will change this to band 2, which is the band that I have used, that I have created last. Unfortunately, then my color map disappears, so I just have to import it again. And I click OK. And now I only have the moderate low to high severity burn areas. I'm sorry, my mouse seems to have run away from me. Okay, so this is the area, and now what you can do as a last step, just out of interest, is to, if you have the Open Layers plugin installed, you can go and, for example, import the satellite high-resolution satellite data. just drag them under so I overlay them. And then you can see where the burn areas occurred. Okay, so this is basically it from me for the exercise. One last thing, if you would like to then download the results from the virtual machine, you have to press Ctrl-Alt-Shift, and then this window will be open here, and you can navigate to any folder that you have on your virtual machine where you have the data saved. And if you double click any file, it will be automatically downloaded to your computer. The same way, if you want to upload files to your virtual machine, you just navigate to a folder where you would like to save them in your virtual machine, and then click upload. It will open browser in your file browser in your computer, and you can select file to upload. And then close again with Ctrl-Alt-Shift. Okay. So this is all for the practical exercise. Let me go back to the presentation really quickly, since I know we are running out of time, and just some take-home messages. So I hope what you will take away from this webinar is that you can use very nicely Sentinel-2 data to retrieve the burnt areas using the reflectance properties in near-infrared and shortwave infrared bands. That the RUS service can help you to do this. You can repeat the exercise on the RUS service. It's free and open to anyone, and you can use it also for additional projects that you may have, or just to exploit Sentinel Copernicus data. And you can, there is a software pre-installed on the virtual machines, and also a dedicated help desk with EU experts that can support your activities, whether it's development or data exploration. And we also provide webinars, so the next webinar, such as this one, of course, and the next webinar is going to be on the 16th of January. It is yet to announce topic. Just last thing, the code to repeat this exercise that also will be, if you provide this code when requesting the virtual machine, you will be provided a virtual machine that has all the necessary software and all the necessary data on it to repeat this exercise. And also it contains step-by-step PDF with everything explained, so maybe that will be better than my explanation here, but hopefully that's going to help you anyway. And I think that would be all for me. Okay, thank you very much for listening, and have a nice afternoon, and I hope you have enjoyed the webinar.